How autonomous flying systems are changing aviation. For most of aviation history, flying depended entirely on human pilots. Training, experience, and judgment were always at the center of flight. Every decision in the air was made by a person. But today, that balance is slowly beginning to change. Autonomous systems are moving from the ground into the sky. Not suddenly, not dramatically, but step by step. And aviation is starting to transform in ways most people don't fully see yet. Drones were the first real proof that autonomous flight could work. They showed that machines could stabilize themselves, navigate complex environments, and react to changes faster than humans. At first, drones seemed limited, small, simple, useful mostly for cameras. But beneath the surface, something important was happening. The same technologies that kept drones stable in the air were quietly improving. Sensors became more precise. Software became more reliable. Decision-making systems became faster. What started with small unmanned systems is now expanding into larger and more complex aircraft. Autonomous aviation does not mean removing pilots overnight. That is a common misunderstanding. Instead, it means gradually shifting responsibility from humans to systems. Many modern airplanes already rely heavily on automation. Autopilot manages altitude. Software assists with navigation. Systems constantly monitor safety conditions. Pilots are no longer controlling every movement. They are supervising systems. Autonomy enters aviation quietly, one layer at a time. For autonomous flight to work, aircraft must understand their environment in real time. This requires perception. Modern flying systems use radar, LiDAR, cameras, and satellite data simultaneously. They detect weather patterns, terrain, obstacles, and nearby aircraft. All of this information is processed continuously to create a live model of the sky. Flying is no longer just about movement. It is about awareness. An aircraft must see before it can act. Scaling autonomy from drones to airplanes and helicopters is extremely difficult. Planes operate at high speeds. Helicopters deal with unstable airflow. Both function in environments where small mistakes can have serious consequences. This is why aviation autonomy progresses slowly. Systems must be redundant. They must fail safely. They must behave predictably in rare situations. In aviation, reliability matters more than speed. Progress may look slow, but slow progress in aviation means safe progress. As autonomy increases, software becomes the primary decision maker. Algorithms manage flight paths, optimize fuel usage, and assist with emergency responses. The aircraft becomes less of a mechanical machine and more of a flying system. Control gradually shifts from physical inputs to software logic. This does not remove humans from the loop. It changes their role. Humans move from direct control to supervision and strategy. Autonomous flying systems will not replace aviation. They will reshape it. Flights may become safer, operations more efficient, human involvement more focused on critical decisions. The sky will not become empty of pilots, but it will become increasingly automated. What matters most is not the absence of humans, but the presence of intelligent systems. Autonomous flight is not a sudden revolution. It is a quiet transformation. One system at a time, aviation is becoming software-driven. And while most people look at the sky and see no difference, the future of flight is already taking shape above us. What is happening in aviation today is not about replacing pilots. It is about redefining how responsibility is shared between humans and machines. Autonomous systems are being designed to handle routine situations, monitor complex environments, and react faster than human reflexes. Humans remain essential, but their role is changing. They are becoming managers of systems, not operators of every action. One of the most important advantages of autonomous flight is consistency. Human performance can vary. Fatigue, stress, and distraction affect decision-making. Software does not get tired. It does not lose focus. It executes procedures exactly as designed. This does not make software perfect, but it makes behavior predictable. And in aviation, predictability is critical. Another important factor is scalability. As air traffic increases, managing the sky becomes more complex. Autonomous systems can coordinate, share data, and optimize routes across large networks. Instead of isolated aircraft, aviation becomes a connected system. Each aircraft is no longer acting alone. It becomes part of a larger intelligent network. This shift also changes how aircraft are designed. Future flying systems will be built with autonomy in mind from the beginning. Sensors will be integrated more deeply. Software will be as important as hardware. Updates will matter as much as maintenance. Aircraft will evolve continuously, not only between generations, but during their operational life. Public perception often lags behind technology. To many people, autonomous flight still feels distant or unrealistic. But in reality, automation is already deeply embedded in aviation. The transition is not coming. It is already happening. Quietly, gradually, system by system. The real challenge is not technological. It is organizational, regulatory, cultural. Aviation is one of the most safety-critical industries in the world. Change must be proven, tested, and trusted. This is why autonomy enters the sky slowly, but once it does, it rarely moves backward. In the end, autonomous flying systems are not about removing humans from the cockpit. They are about building systems that support human decision-making at a level of complexity that was previously impossible. The future of aviation will be shaped by collaboration between people and machines, and that collaboration is already redefining what it means to fly.